So let me check. Okay, now that is recording, right?
Yes, Lausche.
Okay, okay, thank you. And here, for this function, you cannot find, on this graph, you cannot find a horizontal tangent, a horizontal line, right? Because at this point, the tangent line, that is this one, right? So you cannot find. So here, if a function that does not satisfy the first condition, so you can not find the point satisfies the conclusion here. So for the second, that is, if a function that is fx equals to absolute value of x, and x is from -1 to 1 closed interval, and we know the graph that is like this, right? This is -1 and here is 1. So you know at this point, 0, the function that is not differentiable, right? Fx is not differentiable at the point x equals to 0. And we have proved it before. So for this function, you cannot find a point satisfy the conclusion either. So number 3, the second case, that is, if a function that equals to x and x from 0 to 1. So you will find this is the graph of this function. And here, the values of two endpoints, they are not the same. Here 0, here 1, right? They are not the same. And we cannot find a point satisfies the conclusion either. So the here, the above 3 examples shows that a function should satisfy all the 3 conditions, then we can find the conclusion here. So here is the Rolle's theorem. Here the Rolle's theorem. And the second, we call it the mean value theorem, that is a Lagrange theorem. You will find that the Rolle's theorem is a special case for the Lagrange theorem. So the Lagrange theorem says if a function fx satisfies the following 2 conditions. The first, that is continuous at the closed interval from a to b. And the second, that is the function is differentiable in the open interval from a to b. Then we can get a conclusion here. That is, we can find at least 1 point. C in the open interval from AB, which satisfies that FB minus FA by B minus A equals to the value of the derivative at this point. Oh, sorry, C here. C here. And we will also show the theorem as a graph. And you can see from the graph here, the graph does not satisfy the third condition of the Rolle's theorem, right? So this is a continuous and differentiable function, and maybe this point is A, this point is B, and this theorem tells us that if we connect A and B, these 2 points, we connect it here from A to B. And the left part, FB minus FA by B by A, that means the slope of this line, right? So here, FB minus FA by B minus A means the slope of the chord AB, maybe this point that is A and this point that is B. So that is the slope of the chord AB, right? And we can find a point in this open interval that the tangent slope of this point is also equals to the slope of the chord AB. So we can find a point C, maybe this point that is C, and the tangent line maybe like this. And we will find the tangent line at this point that is parallel to the chord AB, right? So the mean value theorem or Lagrange theorem tells us you can find a point between A and B, and the slope at this point that is equal to the slope of the chord AB. So here are 2 mean value theorems we often use. And here I will show how to use these 2 theorems here. So here we will consider some questions about proving. So here, the first, that is, functions with 0 derivatives are constant. That means, here first, if a function, the derivative of this function always equals to 0 at each point x of an open interval AB. If a function, the derivative of this function always equals to 0 at each point x of an open interval AB, then we can get that the function is a constant function for all x in this interval AB. And C here is a constant. From the formula, we have learned that the derivative of a constant always equals to 0, right? So here we want to prove if a function, the derivative of this function always equals to 0, we can also get the conclusion that it is a constant function. So here we will try to prove it by the theorem, the mean value theorem above. So here we can choose 2 points. We can choose 2 different points in this open interval. So if I want to prove that the function is a constant function, that means for different points, maybe x1, x2, they are different in this open interval, right? But f of x1 equals to f of x2, right? And x1, x2, x1, x2, I choose from this open interval for whichever. So here we can find two different points here. X1.
Lashi, why you wrote this one? Three line, it's equal or
Okay,
others?
three line here means always equals to. No matter which value x you choose in this open interval, it always equals to 0. Or you can write equal to. You can write equal to.
Got it, Lashi.
Okay, so here we find two different points here. X1, X2 here. And here we can find that x1, x2 are two different points in this open interval, but it can make a new interval, a new closed interval from x1 to x2, right? We can make a new interval from x1 to x2. And now we can calculate, because the function f of x is continuous at this interval, and that is differentiable at this open interval, right? Because we have proved that if a function that is differentiable, that is continuous, right? So here, from the condition, we have f prime x equals to 0. That means the function is not only differentiable, but also continuous, right? And the closed interval from x1 to x2, it is a subset. This symbol means subset of this open interval, right? And here, so we know f of x, this function, must be continuous and differentiable in this interval from x1 to x2. And that is continuous on the at the closed interval from x1 to x2, and differentiable at the open interval from x1 to x2, right? So here we can use the Lagrange theorem. That means f of x1 x2 minus f of x1 by x2 minus x1 equals to f prime c, right? From the theorem here, if a function that is continuous and differentiable here, we can find at least one point, right? That means f prime c equals to 8. So here, we just substitute x1, x2 in the formula, in the equation here. So we can find there exists at least a point C in the open interval from x1 to x2. And this equation holds, right? And then from the condition here, f prime x always equals to 0 at each point of x, right? So here we know f prime c must be 0 here from the condition, So that means f of x2 minus f of x1 by x2 minus x1 equals to 0. And we let x2, x1 be two different points in this interval. And that means x2 minus x1 does not equal to 0, right? So a value by a value equals to 0, that means f of x2 minus f of x1 must be 0. And that means f of x2 must be equal to f of x1. So every pair of 2 points x1, x2, we will always find f of x2 equals to f of x1, right? So that means fx is a constant function. We can let it be c, the constant c here. So we use the Lagrange theorem to prove that if a function, the derivative of a function always equals to 0 at an open interval, that means this function must be a constant function. So any questions about this example? About the proof? Any questions?
Lastly, could you please graph it?
Graph it, okay? That means you can see here. Here, if a function is a constant function, that means maybe this point is C. That means it is a horizontal line here. Y equals to f of x. That means every different pair, every different 2 points in this interval, maybe the interval AB that is here, A, here, B. And I choose 2 different points inside this interval here, x1, x2, and they are different points. And I have proved that no matter how I choose these 2 points, the values of these 2 points are always the same, So we know this function is a constant function. Because if it is not a constant function, maybe like this, I choose 2 different points, x1, x2, right? And the value of these 2 points cannot always be the same. Here, they are not the same. And maybe the function can be here. First goes down and horizontal, and then goes up. So maybe you will say that I can choose 2 points here, right? Because here the values of these 2 points are the same. But no matter how I choose these 2 points, right? So here you can also choose the point x1 here and x2 here. This time the value of these 2 points are not the same, right? So here we have proved that the function f of x must be a constant function, So any other questions, or am I clear?
Thank you, Laoshi. Clear.
Laoshi, can you show another example?
Another example, okay, of course, here. Another example here. If f prime x always equals to another function, g prime x, at each point x in an open interval AB. Then there must exist a constant C such that fx equals to gx plus c for all x in AB. So this question tries to tell us functions with the same derivative differ by a constant. And we know if fx equals to gx plus c, right? And we can differentiate the equation on both sides. So f prime equals to gx plus c prime. So that equals to g prime plus c prime. And c is a constant here. So c prime equals to 0. So that equals to g prime x, right? So we know if fx equals to gx plus c, then f prime x must be equal to g prime x. So here, I want you guys to prove that if f prime equals to g prime, we can also get the conclusion that f prime fx equals to gx plus c. The inverse is also correct here. So we try.
And C is 0, Laushi. C is 0 here because it is prime.
No. C can be any constant. C can be any constant. Yeah.
This one, Laushi. This one. Sorry.
Yeah. Plus 0. Yeah, plus 0.
Yeah. Okay, got it.
Yeah. So here I will give you 2 minutes to think about it. And we also use here. We use the conclusion of this question we have just proved here. We use the conclusion of this question. So in the book, this example and the example 2 here, they are called corollaries of this theorem. So number 2, the second question, we use the conclusion of the first one. So try to think about it. Why f prime equals to g prime? Then we know fx equals to gx plus c. Here is only one condition here. That is f prime equals to g prime. And I'm trying to find another example to practice. The proof is not hard here. So here we can let fx minus gx be a new function, hx. So first we suppose that hx equals to fx minus gx. And we differentiate on both sides. And that means h prime equals to f of x minus g of x prime, right? And that equals to f prime minus g prime. And from the condition, we know that f prime always equals to g prime, right? So that equals to 0. So we find that h prime always equals to 0 here. H prime always equals to 0 here. So from the question 1 here, if the derivative of function always equals to 0, that means it is a constant function, right? So here we know hx is a constant function. So here we know.
Lasha, how can be it 0? Can you explain?
Okay, here we let hx equals to fx minus gx, and we calculate the derivative on both sides. So
Yes.
we have h prime equals to fx minus gx outside prime, right?
Yes,
And here we use the sum rule or the difference rule that equals to f prime minus g prime, right?
Yeah, Lasha, got
And
it.
from the condition here,
Yeah.
the condition that is f prime always equals to g prime at each point x. So that must be 0, right? They are always the same. They are always the same. So that equals to 0. And
There is x equal to 0. There is x equal to 0. So fx equal to 0 minus g of x equal to 0 equal 0. Am I right, Laushi?
here f prime x equals
Prime x equals g prime x.
Yeah, for all x for each point x means all x in this open interval that satisfies f prime x equals to g prime x. And x here, they are the same. You know that? Maybe I choose x1 from in AB. That means
What is the value of x, Laushi, here? Here, what is the value of x? 0.
Here, we don't have 0.
Basically, you want to say what's the value of x?
Value?
Yeah, Ella, she asked, what's the value of x?
The value of x, right?
Yeah, yeah.
The value of x, we can choose each point, every point in this open interval. So we can choose x1 in this open interval that f prime x1 equals to g prime x1. Or we can choose x2 in this interval and f prime x2 equals to g prime x2. As long as this point is in this open interval.
I got it, Laushi, but I could not get it that how can be f prime x equal 0?
Because they are the same. They have the same value, so that equals to 0.
F prime x equals g prime x. Equal. This is equal.
Okay.
Here, x.
Okay, got it, Laushi. Sorry for that. Got it.
Sorry,
তুমি
I
যদি
am confused.
f prime
I
x
am
এর মানটা
confused
g prime x বসাও তাহলে তো হয়ে যাচ্ছে এটা সিম্পল ভাবে।
Actually, Laushi, I had not been thinking like that way. That's why it was critical for me. Okay, got it, Laushi.
Okay. So here we know that the function hx is a constant function, and that means fx minus gx equals to the constant c, and that is what we want, because we want fx equals to gx plus c here. This is the conclusion, right? So we have completed the question, the proof of the question. So here are the questions. And the x here, that is arbitrary in this open interval. Okay, and then I will show you two more examples here. And these examples is about the Rolle's theorem and the Lagrange theorem. How to check. So first, maybe that is number 3 or 4. Okay, here. I gave you a function, the function that is fx equals to x plus 1 by 2x. And the function satisfies the Lagrange theorem on which interval, or on which interval the function satisfies the Lagrange theorem. And the first interval, that is from 1 to 2. Second, that is from -2 to 2. The third, that is from -2 to 0. And the last one, that is from 0 to 1. So how does it mean that the function satisfies the Lagrange theorem? Because Lagrange theorem has two conditions, right? And that is the function should be continuous and differentiable, right? The function should be continuous at the closed interval and differentiable in the open interval. So can you guys try to choose the correct answer? On which interval, at which interval the function satisfies the Lagrange theorem? Can you find a special point for this function? The function here. Which point do you think that is special for this function? Or at which point the function is not defined?
0.
Yeah. So you will find at the point 0, the function is not defined, right? So that means this point, we don't have the definition here. So at this point, the function cannot be continuous, right? Can you understand, guys? Can you understand?
No, Lasha.
Repeat number D.
Okay. So here, maybe for this a easy function, x 1 minus x. The graph of this function, that is like this. So you can see if x equals to 0, the function is not defined, right? So from the graph, you can see at this point, the function cannot be continuous because the curve of this function cannot pass this point. Can you understand? If the function is not defined at this point, that means the curve, the graph of this function cannot pass this point because that is not defined. That is not defined. So here, similar here, x should not be 0, right? If x equals to 0, the function is not defined. So at this point, the function is not continuous. So from the intervals above a, b, c, d, if the intervals includes 0, the point 0, that must make the function not continuous, right? So here you can see 0, 0, and 0 is in this interval from -2 to 2, right? So B, C, D are all not correct. We choose A here. Can you understand why I choose A?
Not really, Laoshi.
Okay, so here for the Lagrange theorem here, we want the function is continuous at the closed interval and differentiable in this open interval, right? So the curve at the closed interval should be continuous. There must not be a hole on this curve. So here you will find for this function, x plus 1 by 2x, or you can write like this, that equals to x by 2x plus 1 by 2x, right? And here x can be cancelled, so that equals to 1 by 2 plus 1 by 2x. So here, for this function, x cannot be 0. Because if x equals to 0, 1 by 2x is not defined. So the function cannot pass the point x equals to 0. So so 0 cannot appear in the interval. So that is why we choose A. We choose A here. So you can write down this example and try to think about it after class, okay? And if you cannot still understand, you can talk to me about your questions, okay? So here we have learned the mean value theorems. And this part, I know that is abstract and a little bit hard to understand. Not only for you, for all the freshmen who learned advanced mathematics. They all think that this part is a little bit hard to understand. So just try to understand by graph. Here, every part, I draw the graph on the right? So try to understand by graph. And for this part, you should remember the conditions of the Rolle's theorem and the Lagrange theorem. the conditions of the Rolle's theorem and Lagrange theorem. You should remember that. Okay, so this is the first part. We have learned the mean value theorems, and then we will learn something easier, right? Okay, so here, let's turn to part 2. We will learn something easier. We will learn how to sketch the graph of a differentiable function. And here first, sketching the graph. So first, we will learn what is monotonic functions. And maybe some students have learned monotonic functions in high school. And here we say if f is a function defined on an interval, and x1, x2 are 2 points in this interval. So here we have a function f of x, and the function is defined on this interval I, and we choose 2 point x1, x2 in this interval. So first, if f of x1 is smaller than f of x2, wherever or whenever x1 is smaller than x2, then we call the function f is increasing. So you will find on this interval I. So you will find x1 is smaller than x2, and the value of x1 is also smaller than the value of x2. So the curve must go up here, because here is x1, here is x2, and the value of x2 is larger than the value of x1. So here we call the function is increasing on this interval, increasing here. So I think this is easy to understand, right? We can see the curve is going up. So that is increasing. And here, what means decreasing? Decreasing means f of x1 is larger than f of x2 whenever x1 is smaller than x2. We call it decreasing. So you can see here, x1, right? x2 here. And x1 is smaller than x2, but the value of x1 here is larger than the value of x2. So we will find the curve that is going down, right? So that is decreasing, that is decreasing. So can you understand, guys, what is increasing and decreasing? Any questions here?
Lashi, please can you repeat again?
Okay, so f is a function and I is an interval, and we choose 2 point x1, x2 in this interval. And x1 is smaller than x2. x1 is smaller than x2. So we can see x1 is on the left, x2 is on the right, right? So if f of x1 is also smaller than f of x2. So here you can see this value is the value of x1, right? And here is the value of x2. So f of x1 is smaller than f of x2. So we can see the curve is going up. So that is increasing. And here, if f of x1 is larger than f of x2, so we can see the curve must be going down, right? So that's
Actually,
decreasing.
this sign is maybe
Which sign?
this sign is maybe relatively different. This
Smaller?
one, this.
No. Smaller.
Okay, Marcy.
Okay, here. X1 is still on the left. X2 is on the right. But here, we change here. Can you find? F of x1 is larger than f of x2. Okay, I will give you another example. And this function appears again, y equals to x squared. Here. Okay, the graph of this function is like this. Okay, here, like this. So from negative infinity to 0, from negative infinity to 0, you can see that the curve of this function is going down, right? So that means in the interval from negative infinity to 0, the function f is decreasing, right? Because you can see here, I choose maybe this point is -2, and this point that is -1. So we can substitute -2 and -1 into this function. You will find that f of -2 equals to 4 and f of -1 equals to 1. So although -2 is smaller than -1, but f of -2 is larger than f of -1. So we call the function is decreasing. -2 here.
Got it. Yeah.
Can you understand?
Yes, Rosie.
Okay. So we call it decreasing. And here, we can choose 1 and 2 here. So you will find f of 1 equals to 1, f of 2 equals to 4, right? So 4 from 0 to positive infinity. Although 1 is smaller than 2. And f of 1 is also smaller than f of 2, right? So we know in the interval from 0 to positive infinity, f is increasing. F is increasing. Can you understand, guys? Here?
Yes, Rosie.
So here you can also find, I will draw here. For the function y equals to x, this is a line, passes 0. So you can see, for this function, I can choose, maybe this is -1, and this is 1. -1 is smaller than 1, and f of -1, that equals to -1, right? is also smaller than f of 1 equals to 1. So the function is increasing. So you can see whenever you choose 2 points, you will always find the value of the smaller one is also smaller than the value of the larger one, right? So you can choose here maybe -1/2, here 2, right? That is always at this. So the function y equals to x is always increasing from negative infinity to positive infinity. F is always increasing here, right? And here I will give you another example. So please tell me the absolute value function. In which interval the function is decreasing, and in which interval the function is increasing? Can you tell me, guys? Do you know the graph of this function? Remember that? Or any questions here?
Oh, shit. No
Okay.
questions.
My question is, in which interval the function is decreasing, and in which interval the function is increasing?
Also, from -infinity to 0, the function is decreasing, and from 0 to plus infinity, the function is increasing, I think.
Yeah.
And the graph will be like this way.
Yes. Right. Correct. So don't remove it. From the pink graph here, you can see from the minus or negative infinity to 0, we will see that the graph is decreasing, right? And from 0 to positive or plus infinity, the graph is increasing. So we can find that is the answer, that is from negative infinity to 0 is decreasing, and from 0 to positive infinity, the function is
Increasing.
increasing. So we can find the intervals, but here is a question that we found the intervals for the above examples by the graph, right? By the graph. But if the function is complicated, and we cannot draw the graph directly, so how to find the interval that the function is increasing and the interval that the function is decreasing? So here we will learn a theorem here. That is, we suppose the function is continuous. It should be continuous here. On a closed interval and differentiable in an open interval. And the condition here, that is the same as the Lagrange theorem, right? Then we know if f prime x, the derivative of the function, if f prime x is always larger than 0 at each point x in the open interval AB, we can get f is increasing. And if f prime x is always smaller than 0, then the function f is decreasing. Is decreasing. So here we can use the derivative, the sign of the derivative, to know at which interval the function is increasing and decreasing. So here, let's check the theorem here. Oh, here. Okay, first let's check the function y equals to x squared. So I will write here with the green color. So here y equals to x squared, right? And we know y prime equals to 2x, right? And here I want to find the interval that fx is increasing. So from the theorem, we know if fx is increasing, that means f prime equals to 2x should be larger than 0. Then the function is increasing, right? And if 2x is larger than 0, that means x should be larger than 0, right? So we know if x is larger than 0, then the function is increasing. Yes, here, they are the same, right? And if y prime equals to 2x is smaller than 0, then from the theorem, f is decreasing. So that means 2x is smaller than 0, x should be smaller than 0, then f is decreasing. We got the same conclusion here. So we know we can get the interval by graph or by derivative. We have the same conclusions. We find the same intervals here, right? So we check the second here. The second here, that is y equals to x, right? So here we know y prime equals to x prime here equals to what? Equals to 1, right? And 1 is always larger than 0, right? Yeah, so we know that the function is always increasing from negative infinity to positive infinity. So here we get the same conclusions here. Can you understand? Can you understand, guys?
Yeah, Lashi, got it.
Okay, and the last part that is here. y is absolute value function. And absolute value function means if x is larger or equal to 0, y equals to x, right? And if x smaller than 0, y equals to minus x, right? So we know if x is larger or equal to 0, y prime equals to x prime equals to 1. And that is always larger than 0. That means if x is larger or equal to 0, that means the function is always increasing. So we use the symbol here to represent increasing. And if x is smaller than 0, x is smaller than 0, y prime equals to minus x prime. So that equals to minus 1, right? That is always smaller than 0. And that means if x is smaller than 0, the function is always decreasing. So we have the same conclusions here. We have the same conclusions here. Here, the point 0, you can write. And you can, if we don't write 0 here, equal here, that is also okay. Because decreasing and increasing, that is the behavior of a function in an interval, not at a point. So you can write equal to 0 or not. Both are okay. So can you understand this example from the theorem, how to check? Guys, any questions here? No questions?
Yes, Lashi. No
Okay.
question.
No question, right? So this part, I think that is a little bit easier, right? We can understand. So, okay, here, I will give you an example here. Use this theorem. So here, the example is the function that is x power 3 minus 12x minus 5. And first, the questions is first, find the critical point of this function f. The second question, that is, identify the intervals on which f is increasing and decreasing. And I will check the question in the dialog box. So please try to first solve this question by yourself. Do you remember how to find critical points here?
Yes, Lashi.
Okay, we have learned last week. Okay, let's solve this question. Anyone? Okay. Let me check. Yeah, you have find the critical points, but okay, here. Let's first solve question 1. Question 1, we want to find the critical points of f, right? And you know, first, we have to calculate the derivative of this function. So that is f prime here. And f prime here equals to 3x squared minus 12, right? And we can take 3 outside, that is x squared minus 4, right? And here, I found maybe you, why you all missed 1 point? Why you all missed 1 point? Here, f prime equals to 3 times x squared minus 4, right? And we let it be 0. So that means x squared equals to 4, right? Here. That means x squared minus 4 equals to 0. And that means x squared minus 4. So if x squared equals to 4, x should be 2. And x should be what?
-2.
Yeah, minus 2, right? So x can be 2 or minus 2 here, or minus 2 here. So most of you write x equals to 2.
Rasha, how can I get both of them? It's for root over. It's for root over.
Because
Plus and minus.
yeah,
We have got 2 and minus 2. It's
Yeah.
for root over 4. Am I right?
Yeah, x squared equals to 4, then x can be 2 or minus 2. Because for this function, the domain of this function is all real numbers. So x can be 2 and x can also be minus 2, right? So,
Yeah, Lashi.
yeah. So we cannot remove any value of it, right? So here we should write x equals to 2 or x equals to minus 2 here. So here we find two critical points of this function. The first, that is 2, and the second, that is minus 2. So this is the answer for the first question. Can you understand?
Yes, 老师.
Okay, so don't forget to write this part, x equals to minus 4, minus 2 here. And second, we want to find the intervals on which f is increasing and decreasing, right? So here you can see the critical points 2 and the critical points minus 2 have divided the interval, the all real numbers into the domain of this function into intervals 3. First, that is, maybe this is the real line, right? And here is minus 2. Here is 2. So these 2 points divided the domain into 3 parts. The first part, that is this part, that is from negative infinity to minus 2, right? And the second, that is from minus 2 to 2, right? And the last part, that is from 2 to positive infinity, right? So these two critical points divided the domain into 3 intervals here.
Can you explain again, Laoshi?
Okay. So here, from the theorem, if I want to find in which intervals f is increasing or decreasing, here we should know in which interval f prime is larger than 0 and in which interval f prime is smaller than 0, right? And the first step here, we have find that at the point 2, f prime at the point 2 equals to 0, and f prime, the point minus 2, also equals to 0, right? So now we know these 2 points has divided the domain into 3 parts. We just have to consider these 3 intervals to check in which interval f prime is larger than 0 and in which interval the f prime is smaller than 0. Because the point minus 2 and the point 2, f prime equals to 0, right? So here, we just consider the first interval, that is minus infinity to minus 2. Second, minus 2 to 2. And the third, that is 2 to positive infinity. So here, to make it clear, you can write like a table. So the table may be the first row, that is intervals. And the second row, that is f prime. And the third row, that is sine of f prime. Sine of f prime. And the last row, that is the behavior of the function f. So here, we can write like a table here to make it clear. So first, we know the intervals, that is from minus infinity to -2 here. And here, we put the point -2 here because we know f of -2, f prime of -2 equals to 0. And next, that is from -2 to 2. And then we also write 2 here because here f prime also equals to 0. And then the last interval, that is from 2 to positive infinity. So here you should check f prime in this interval and these two intervals. So how to check the value of f prime here? So here, there is a scale here. Okay, I will write here. I will write the tips here. Find or choose a special point of the interval. And calculate the value of this point. Here, the value means the derivative. Okay, so here, from minus infinity to -2 here, the special point here, I want to choose, that is 0, right? So you can see 0 obvious in this interval from minus infinity to -2, right? And 0 is a special point because it is easy to calculate the value of this point, right? So don't forget here, f prime x equals to 3x squared minus, oh, sorry. Here, 0 is not okay. 0 is here, right? 0 is here. So here you can choose maybe -3. So the f prime function, that is 3x squared minus 12, right? So I can choose a point -3.
How can I choose -3? It's from ourselves.
Okay, you can also choose -4, -5.
Anything I can choose.
Yeah.
It will be minus, am I right?
Yeah, any point you think that is special in this interval.
Okay.
Okay, so here I choose -3 here, and I substitute -3 in this function. So we know f prime -3, that equals to 3 times 9 minus 12, right? So that equals to 15 here. 27 minus 12, right? 15 here. So you can see the sign of f prime, that is positive. That means f prime is larger than 0. So the behavior in this interval, that is increasing. I will.
Lashi,
Okay, I will.
I'm not clear about 15.
Huh?
I'm not clear about 15.
Okay, 15.
Yeah.
Substitute -3 into the derivative of the function. The function, that is 3x squared minus 12, right? So f prime here, okay, I will write here. F prime -3 equals to 3 times -3 squared minus,
27 minus 12.
yeah. So here,
12,
that is
15.
27 minus 12 equals to 15. Understand?
Yeah, Lashi, got it.
Okay.
Lashi,
Yeah.
Lashi, what happened if I take a 0 there? I mean,
Here, the interval that is from minus infinity to minus 2. That means,
okay.
yeah, the value should be smaller than minus 2.
-2. Yeah,
Yeah,
Lashi, I
yeah,
understand.
yeah. So I choose minus 3 here. Or you can choose minus 4, maybe, right? F prime minus 4. You can also substitute into this derivative function. So that means 3 times minus 4 squared, right? Minus 12. And that equals to 3
Okay.
times 16 minus 12. That equals to 48 minus 12 equals to 36, right? And that is also larger than 0. So you can choose a point as long as the point is in this interval. The point is okay. So the first, we choose minus 3, and we substitute minus 3 into this function to get. Then we know the sign that is positive. So we know the function is increasing. Okay, guys. And then here, for this interval, now we can choose 0 here, right? Because 0 is in this open interval from -2 to 2. Okay, so here we can choose 0, then we check f prime of 0. That equals to 3 times 0 squared minus 12, right? And that equals to minus
12.
yeah, minus 12. That means the sign here minus 12. F prime 0 equals to minus 12. And the sign here, that is negative, right? Smaller than 0. And that means the behavior of the function in this interval, that is decreasing.
Decreasing.
Yeah. And the last part, which value do you want to choose? Of course, we want to choose a point, the value that is easier to calculate, right? So we may choose maybe 3 here. Okay, 3 in this interval from 2 to positive infinity. So we substitute f prime 3 here. That equals to
15.
yeah, the same. 3 minus 3 squared minus 12 equals to 15, right? That is larger than 0. So we know f prime 3 here equals to 15. And that is positive here. So that
Yeah.
the function.
Yeah.
Okay. So any questions about this part? Any question?
no,
No?
Lashi.
Okay. So here we can get the concurrence here. Thus, or therefore, so here we know the increasing interval. Here we found two intervals that is the increasing interval, right? So we know that is the increasing intervals are negative infinity to -2 and 2 to positive infinity. And the decreasing interval, that is from -2 to 2. So here we completed this question. Here is the whole solution for this question. Okay, any questions? Any doubt about it?
No, 老师。
No,
Oh.
老师.
Okay, so this part you can understand, right?
Yeah,
Yes.
Losh.
Okay, okay. So now let's take a break, okay?
Okay.
是。
Okay, 15 minutes.
Hello, hello, 老师。
Yes, yes.
Can you scroll up little bit?
Okay, to where you want to see?
Okay, okay, 老师。
Okay. Let's have a break, guys. Okay, guys, let's back to class.
Okay, let's see.
Okay. So anyone knows today is a special day in China? Do you know that?
Yeah.
Really? Okay.
Is it a rough day?
11.
Maybe students in China, they will know today is a special day in China. Likewise, Black Friday in America. That means today is November 11. So, yeah. So like for sticks. And some students in the campus, they name this day Double 11 or single days. Single days for single people. So at first, this day is a sad day, right? But if we feel sad, maybe we want to go shopping, right? So in recent years, today is a very special day for shopping, and we will get a special discount on this day. And many people stay up late yesterday and to the midnight to buy things they want or buy the things for 1 year. So I think you will learn Chinese traditional culture. So this day, I think you should know, and that is very special. Yeah, single day. Yeah. So if maybe someday you come to China and you will find today is very special for all the people. Okay, so let's move on. So here you want me to give you another example here for this the theorem. Want another example or we can continue?
Another example also.
Okay,
Now
another.
she is said someday, so we are going to China. So when we can go to China? Do you know anything?
Actually, I don't know. I really want you guys to come to China quickly, soon. I think face-to-face class, that is much better than online class, right?
Yeah.
Yes, Lashi, it's better.
Yeah,
It's
yeah,
better in infinite.
yes. I hope that day will come soon. Okay, so here I will give you another example here. Okay, I will write here. The function that is f of x equals to 2x power 3 minus 9x squared plus 12x minus 3. And the questions are same as above. First, find all the critical points. All the critical points. And then identify the intervals. Identify the intervals on which the function is increasing and decreasing. F is increasing and decreasing. Okay, try to solve it. I am not speaking. So can you hear me now?
Yes,
Yes,
class.
you can hear you.
Okay. Okay. double check the procedure. Some students make mistakes when they find the critical points. Just now, I was not talking because we are taking exercises, right? So now I think you can. Okay, so now I think you can hear me now, right?
Yeah, Laoshi, we can.
Yes, Laoshi.
Yeah. So I'm confused what you are talking about. So you mean you cannot understand my English or not?
Yeah, Laoshi, we can hear in English. That's no problem.
Yes.
Which part you cannot understand?
No, Laushi, I say to Rajiv.
Oh, okay, okay.
Sorry, Laushi, I said to Rajiv. Rajiv.
Actually, Laoshi, who is making fun?
Oh, okay, okay. Okay, now let's solve the question together. So first, we want to find critical points. So we have to calculate the derivative of this function. So f prime x equals to, first, that is 6x squared, and then minus 18x plus 12. Then we let it be 0, right? So first, we can cancel the common factor 6 here, right? So that is x squared minus 3x plus 2 equals to 0, right? And then we know that is x minus 1 times x minus 2 equals to 0. So here are two critical points, x equals to 1 or x equals to 2, right? So Oma may be making mistakes here, right? Here, delta equals to minus 3 squared minus 4 times 1 times 2, right? That is 9 minus 10 equals to 1. So maybe you make mistakes here. Try to solve it again. Okay, so first we find two critical points, that is x equals to 1 or x equals to 2. So we know that f prime 1 equals to 0 and f prime 2 also equals to 0. And these two, these two critical points divide the interval, divide the domain into 3 intervals. So the second question, that is here, we know the intervals here, that is 1, 2. So from minus infinity to 1, and from 1 to 2, and then from 2 to positive infinity. So here, maybe we can also make a table here. So f prime x equals to 6x squared minus 18x plus 12, right? So the first row that is intervals. And then f prime, the value of f prime of a special point, right? And then the sign of f prime, and then the behavior of the function f, right? So we know that is first interval from minus infinity to 1 and the point 1. Then from 1 to 2. Then 2. And the last part, that is from 2 to positive infinity, right? And every interval, we can choose special point. At the first, from minus interval infinity to 1, we can choose 0 here, right? So we can calculate f prime 0 here. That equals to 0 minus 0 plus 12, right? So equals to 12. That means the sign of f prime is positive, right? Larger than 0. So the behavior of this function in this interval, that is increasing, right? And then here, from 1 to 2, here maybe we can choose 3 by 2, right? 3 by 2. So we can calculate here f prime 3 by 2. And we
why will I choose 3 by 2 there?
Because we have to choose a point between 1 and 2. You can choose other point.
Got it, logic. Okay.
Okay. So f prime 3 by 2 here, we substitute, that is 6 times 9 by 4, right? Minus 18 times 3 by 2 plus 12. Okay, so that equals to here, that is, let me check, that is 27 by 2 minus 27 plus 12, right? And that equals to 27 by 2 minus 15. That equals to minus 3 by 2, right? So f prime minus 3 by, here is 3 by 2. F prime 3 by 2 equals to minus 3 by 2, right? So that means the sign of f prime, that is negative here. So
it is decreasing.
Yeah, decreasing, good. And the last part here, we can choose 3, maybe. So we just substitute 3 into f prime function. So that is 6 times 9 minus 18 times 3 plus 12, right? And of course, that is larger than 0, right? So positive here, and that is the behavior at this part, that is increasing. So we know that the increasing intervals the increasing intervals that are negative infinity to 1 and 2 to positive infinity, right? And the decreasing interval that is a 1 to 2 open interval, right? So we can get the conclusion here. The increasing intervals are and the decreasing interval is from 1 to 2, right? So here we completed the question. And here we will find one thing here. We know the behavior of a function. So now we can see if a function, if a graph, if a curve passes a point, maybe this point that is C, this point C, and the function, the curve passes this point. And if first the curve goes up, and after this point, the curve goes down, we know this point must be a local maximum. Remember that? Local maximum we have learned last week. Remember that?
Yes, yes, for sure.
Okay, so if also a point C, if the curve first goes down, then after this point, it goes up. That means this point is local minimum, right? And here we have learned if the curve goes up, that means the curve is increasing, right? That means f prime is larger than 0, right? And the curve goes down, that means the function is decreasing. So f prime is smaller than 0. So we can get a test. We call it first derivative test for local extrema. So we can use the derivative to find the local extrema. So first, the condition is, the condition is C is a critical point. Of a continuous function f. And f is differentiable at every point in this interval. And here, if f prime changes from here positive to negative at this point C, at C, we know f has a local maximum at this point C. And if f prime changes here from negative to positive, at the point C, then the function f has a local maximum at this point. So here we can use the sign of the derivative to test this point, if it is a local extrema. It is local extrema. And the first, the second case, and the third case, maybe you will find f prime, the sign of f prime does not change, right? F prime, the sign of f prime does not change. So we know that f has no local extrema at this point. At this point. Okay, first I will explain the third case. This case, I will explain it. Maybe we can consider this function y equals to x power 3. So here, guys, you will find y prime equals to 3x squared, right? And that means no matter which value of x is, y prime always larger or equals to 0, right? Because y prime equals to 3x squared. Squared means always larger or equals to 0. So that means although x equals to 0 is a critical point, right? Because we let y prime equals to 0, that means x equals to 0. So x equals to 0 is a critical point. But the sign of f prime does not change when the function passes this point. So that means this point is not the local extrema. So that's what the third case means. That means if f prime does not change, then even if the point is the critical point, that is not local extrema. Can you understand?
Repeat, please, Laushi.
Okay. Okay. Here.
Yes, Laushi, understand.
Okay. Here, I will repeat again here. The function that is y equals to x power 3 and y prime equals to 3x squared, right? And we let it be 0, so we can find the critical point x equals to 0, right? And if we look back to y prime here, we will find that 3x squared must be larger or equals to 0. So it cannot change the sign before and after the point x equals to 0, right? So we know f has no local extrema at the point x equals to 0 because the function is always increasing. The function is always increasing. So,
what is the mean of extrema there, Laushi?
Sorry?
What is the mean of extrema here?
Extrema here, that means local maximum and local minimum.
Okay, got it, Laushi.
Okay. So here we know the sign of f prime must change before and after this point. So we look back to the above two questions here. First, this one. First, this one. So here, guys, you will find the critical point that is -2 and 2, right? And before -2, f prime that is positive. And after -2, the sign of f prime that is negative. So we know this point, -2, should be what? First increasing, then decreasing. So at this point, the function has a local maximum, right? So this point should be local maximum. And at the point 2 here, first, the function decreasing and then increasing. So at this point, the function has a local
minimum.
Yeah. So can you get that? Guys, can you understand here?
Yes, Laushi.
Okay.
Yes, Laushi. Side always understand, Laushi.
Okay.
Rajiv also understand Laushi. Rajiv, do you have any questions?
Laushi, they are making fun.
Okay. Okay, here. We also find here at the critical point 1 here. First, the function increasing and then decreasing. So this point that is also local maximum. Okay, then at this point 2, first the function decreasing and then increasing. So at this point, the function has local minimum. So we can substitute the point x equals to 1 into the original function to get the local maximum and the local minimum. So here, if I want to get the value of local maximum, we have to substitute the point x equals to 1 back to the original function here. Right, to get the value of this function. So here we can get local maximum that is we substitute x equals to 1 back to this function. Remember, to the original function here. So that equals to 2 minus 9 plus 12 minus 3. So that equals to 2, right?
2.
Yeah, 2 here. And then we can also get local minimum here. We substitute x equals to 2 back to the function. So x equals to 2 here. F of 2 equals to 2 times 8 minus 9 times 4 plus 24 minus 3, right? And so we get that is, let me calculate, 16 minus 36 plus 24 minus 3, right? So that equals to what? Right? 1. Okay. So we get the local maximum that is 2, the local minimum that is 1. So we can get the we can find the value of local extremas by the sign, by the first derivative test for it. So that is the applications of derivative for this part. okay? And then we will turn to the last part today. And the last part, we use derivative to help us calculating the limit here. So the last part, and the last part, actually, that is the formula here. And the formula here, we call it L'Hopital's rule. L'Hopital's rule. And it's a French name. So here, L'Hopital's rule help us to calculate the limits for indeterminate forms. What is indeterminate form? Indeterminate forms. Here, what is indeterminate forms? That is 0 by 0 or infinity by infinity or 0 times infinity. So here we have learned before, that is, if I want you guys to calculate, remember that as x approaches 0, then sine x by x equals to, remember that, equals to the important limit.
One.
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 Yeah, 1, right. Yes, and then if I want you to calculate the limit like this, very similar here, sine x minus sine a. A is a constant, and by x minus a. Then how to calculate? We cannot use this one, right?
Actually, one, it will be 1, I guess.
Okay, so here we will use the L'Hopital's rule. And the L'Hopital's rule tells us here, I will first tell you, and then you can check which value it equals to. So here, in the book,
Laoshi,
yes?
is x approaches 0 or approaches a?
Oh, sorry, here, A, thank you,
Okay.
A. Okay, in the book, here are two L'Hopital's rules, two forms of L'Hopital's rules. So actually they are the same. So here first, L'Hopital's rule means if I want you to find as x approaches a, fx by gx. And here, fx, fa and ga both equal to 0 here. So that means that is 0 by 0, right? So we cannot substitute a into it. Then that equals to f prime a by g prime a. Of course, here g prime a couldn't be 0, right? So here we can use this rule to calculate this kind of question. So here we know we substitute x equals to a into it. So that is sine a minus sine a equals to 0, and then a minus a also equals to 0. So it is an indeterminate form, 0 by 0, right? So we cannot substitute a. Then we can use L'Hopital's rule. So that equals to, here, we calculate sine x minus sine a prime. That equals to cosine x minus 0, right? Because, because here, sine a is a constant. So that equals to cosine x. And x minus a prime equals to
1.
minus 0, right? So equals to 1 here. So we know that equals to here equals to cosine x by 1 as x equals to a, right? We can substitute the limit a here at the last step. So that is cosine x by 1 as x equals to a. So that equals to cosine a here, not 1, right? So here is L'Hopital's rule. As long as you find it is 0 by 0 form, actually, or infinity by infinity form, you can use L'Hopital's rule here to find that equals to prime by prime of the function. Okay, so here I will give you another example to show it. Here. The example that is to find the limit as x approaches 0, 3x minus sine x by x here. So first you should check whether it is indeterminate form. So first we substitute 0 here. That is 0 minus sine 0, right? Sine 0 equals to 0. So that is 0. And x equals to 0, that is 0. Okay, so here it is a 0 by 0 form. We can use L'Hopital's rule. And then that equals to prime by prime, right? So here 3x minus sine x prime equals to 3 minus cosine x. And x prime equals to 1. Yeah, so that equals to 3 minus cosine x by 1 as x equals to 0. And that equals to 3 minus cosine 0, right? And cosine 0 equals to 1. So that equals to 3 minus 1 equals to 2. Yeah. So can you follow my steps here? Any questions?
No, Lao Shi.
Which part? Which part, guys? So here, L'Hopital's rule is to help us calculate the indeterminate form. Because if we find 0 by 0 form like this, we don't know how to calculate, right? If that is a form similar to the important formula here, the important limit here.
Laushi,
Yeah.
It is cos 0 degree.
Cosine 0.
Equal 1.
Yeah, we substitute 0 into this function. It is a function, right?
So how can I get 1 from cosine x?
Cos 0 degree equal 1.
Bro, cosine 0 degree is 1.
Okay, I asked people, is it degree, 0 degree? Okay, got it, Laushi.
Okay, cosine 0 means 1. Because the graph of cosine function that is like this. Right? So this point that is 0 and this point that is 1. Cosine 0 equals to 1. And cosine means here, this is the angle, right? And A, B, C here. Maybe this angle, we call it alpha. So sine alpha means A by C. And cosine alpha means B by C, right? So if cosine 0 means this angle is very, very, very small. And the limit that is B equals to C, right? So cosine 0 here equals to 1. Can you understand? So here,
Yes,
maybe,
Laushi.
okay. So you can remember cosine 0 equals to 1 and cosine pi by 2 equals to 0. And sine 0 equals to 1 and sine pi by 2 equals to 1. Okay, we often use this for. Please remove the sign. Okay. So here we use L'Hopital's rule to calculate the indeterminate form. And furthermore, we will find if here I want to find the limit as x approaches 0, then here x minus sine x by x power 3. So guys, you will find first we substitute x equals to 0 here. That is 0 minus 0, 0. And then we substitute x equals to 0 here. So that is also 0. So it is a form 0 by 0. We can use L'Hopital's rule, right? So here, that equals to, oh, sorry, here.
X minus sin x prime
Yeah.
equal 1 minus cosine x.
Yeah, so we first calculate x minus sine x prime. So that equals to 1 minus cosine x, right? And
Yeah.
x power 3 prime equals to 3.
X.
Yeah, 3x squared. So here, guys, you will find, as we have talked about before, that equals to 1 by cosine x by 3x squared as x equals to 0, right? But you will find one thing, that if x equals to 0, then 3x squared also equals to 0, right? And if x equals to 0, then 1 minus cosine 0, that equals to 1 minus 1, also equals to 0. So this function that still is 0 by 0 form, right? So here we can use L'Hopital again here. So in our book, we call it stronger form of L'Hopital's rule. So here I will write here.
If it becomes undefined, you have to find the derivatives of the functions.
Yeah, here, because that is not defined. So we can substitute x equals to 0 into this function, right? So we can, yeah, so we can still not find the limit here, right?
Okay, Laushi.
So here we have to learn the stronger form here. Stronger form of L'Hopital's rule. Okay, so if we find after we use L'Hopital's rule, then the function is still 0 by 0 form or infinity by infinity form. We can use the L'Hopital's rule again. So here we can write that is as x approaches a, fx by gx fa equals to 0 and GA also equals to 0, then that equals to the limit as x approaches a prime by prime. So here we know that 3x squared, x cannot be 0, right? But if we have the sign limit, if we calculate the limit, x can approach 0. That means x is not 0, right? We have learned. So here, when we find, after once we use L'Hopital's rule, it is still 0 by 0, then here we can use it again. So that equals to here. We cannot write like this. We have to write the limit. X approaches 0, 1 minus cosine x by 3x squared here. And we use L'Hopital's rule again. That equals to here. Here. 1 minus cosine x prime equals to 0 minus sine x, right? Because cosine x prime equals to minus sine x. So that equals to sine x. And 3x squared prime equals to 6x, right? So after we use L'Hopital's rule again, we find that is sine x by 6x. Sine x by 6x. And guys, you will find if we substitute x equals to 0 into this function, that is still 0 by 0 form, right? So we can use L'Hopital's rule again. So here, that is sine x by 6x as x approaches 0. And here, guys, we can take the constant. Okay, I will change the color here. We can take the constant 1 by 6 outside, right? And then that is
limit
approach 0, sine x
divided x.
Yeah, here you will find it is the important limit here, right? And that equals to 1. So that equals to 1 by 6 times 1 equals to 1 by 6. So 1 by 6 is the final result. We use the L'Hopital's rule twice, right? So can you follow my steps of this question?
Yes,
Yes, Lausch.
Yeah, can you follow or not?
Yes,
following.
Okay, okay.
We can, Laoshi, we can follow you.
Okay. I will give you another example here. L'Hopital's rule is very useful to calculate the limit. Okay, here, another example here. So we can find this one, that is limit as x approaches 1 ln x by x minus 1, x minus 1. So here, if we substitute 1 into this function, ln 1 equals to 0, and x minus 1, 1 minus 1 equals to 0, right? So it is a 0 by 0 form. So we can use the L'Hopital's rule here that equals to, okay, ln x prime equals to 1 by x, right? And x minus 1 prime equals to 1, right? So here that equals to, we don't have to write limit here because we don't have to use L'Hopital's rule again. We find that equals to 1 by x by 1 as x equals to 1, right? So that equals to 1 by 1 equals to 1. And then we choose another one. Let me find, okay, this example. As x approaches 0, that is 1 minus cosine x by x squared. Okay, guys, try to calculate it. Okay, we first find it is a 0 by 0 type, right? So we use the L'Hopital's rule here. First time, 1 minus cosine x prime equals to 0 minus sine x. So equals to sine x. And x squared prime equals to 2x, right? 2x. So here, if we substitute x equals to 0 to this function, we know that it's also 0 by 0, right? So we can use the limit x approaches 0 sine x by 2x here. And we will find, we take 1 by 2 outside. As x approaches 0 sine x by x. So that equals to 1 by 2 times 1 equals to 1 by 2. So guys, can you understand this question?
Yeah, Laushi.
Yeah, Laushi.
Yeah, Laushi.
Okay, and I will give you some exercise for homework about the L'Hopital's rule. And I will send the homework into the WeChat group. Okay, guys? And if you didn't submit the homework for last week, please send it to my email or WeChat as soon as possible. Okay, guys?
Okay, I sent it.
Okay, Laushi. What
Okay,
if,
Laushi, we already sent all the homework.
Yeah. Okay, I know. Okay.
Laushi, what if you have sent the homework but they sent only one question out of the 2? Can you do the second one?
Which one?
The last homework.
The homework last week?
Yes.
Yes. Okay.
I could did only one, so I did only one and sent it.
Okay. Okay. I will send the solution of the homework last week into the WeChat group. Okay.
Okay, Laushi.
Okay. Other questions about this week?
No, Laushi.
Okay.
No,
Laushi.
Yes.
Rajiv
have a question.
Rajiv has a question.
Question man Rajiv. Yes.
Laushi, how can I push it?
Question later.
Have there any complaint box, Laushi? I'll complain for everybody.
Okay. Maybe sometimes the email will delete some emails. So I will check if your name is not on the list. You can tell me. and I will check again. Or you can send the screenshot of the email you sent it to me, and I will put the smile on the list. Okay, guys?
Send us
Okay,
again
Laushi,
the
I want to say that actually when I send you email, then I cannot get any reply, Laushi.
Oh, okay.
How I can be sure that?
Yeah. I know, and so I will set a auto reply. Okay. So
Laushi.
okay, if I got your email, you will get my auto reply next time. Okay.
Okay.
Okay,
Laushi.
Laushi.
Other questions?
Okay, Laushi. No, Laushi.
No, Laushi.
Okay. So
Wish you Laushi. Wish you
okay.
Laushi.
So see you next week and enjoy the single days. Okay.
Okay,
Laushi.
Laushi. We
Bye
are
bye.
safe.
Laushi, for us, every day is single day, so it doesn't matter.
So sad.
Yes, me too.
Okay. See you next time. Bye.
Bye, Laushi.
Yeah.
Bye-bye.
谢谢老师，
再见，
谢谢。
老师。
Bye. See you next
再
week.
见，再
So,
见。
bye-bye, I'm
Catch
sure.
Laushi.
Hey, bye. Leave me alone.